Hello and welcome. My name is Laura Handley, and I am currently the acting surficial geochemist here at the OGS, filling in for Kayla Dell's mat leave. Today I wanted to give a quick update on the Ambient Groundwater Geochemistry project of the Thunder Bay area. In 2016, the AGGP expanded to Northern Ontario with similar objectives to see if delineating natural chemical trends in groundwater could be possible in Precambrian shield terrain, as opposed to the traditional work in Southern Ontario in the Paleozoics. So far, it's been successful in characterizing numerous controls on groundwater chemistry, including brine mixing, quaternary thickness and composition, and in some cases, bedrock geology. We've now expanded our coverage to include the Thunder Bay area, which represents the furthest north in Ontario that this project has ever been implemented. The study area lies on the Canadian Shield at the boundary between the Superior and Southern provinces. Archean rocks of the Quetico and Wawa-Abitibi subprovinces underlie the northern portion of the study area, while the southern portion is underlain by flat-lying Paleoproterozoic and Emeki group sedimentary rocks of the Gunflint and Roe formations. These units are intruded by Mesoproterozoic diabase sills and dikes associated with the Mid-Continent Rift. Thunder Bay was chosen as a practical region to conduct an ambient groundwater study because it has the highest population in northwestern Ontario, with approximately 8,000 individuals within city limits using groundwater wells as their primary water source. Groundwater quality issues such as elevated fluoride, potential for arsenic associated with periodic shales, and multiple exceedances of the Ontario drinking water standard for sodium and chloride have been identified in the region through a series of historical groundwater work that was completed in the late 70s and early 2000s by the Ministry of Environment and the Resident Geologist Program. However, these parameters analyzed during these studies were limited, with only about 8% of the total samples analyzed for trace parameters, suggesting additional research of minor and trace element geochemistry was required to better understand the full groundwater picture of the area. So with this in mind, the Thunder Bay Groundwater Project will address some of these previously identified water quality issues by hopefully delineating them and possibly identifying the controlling factors. The program also seeks to examine the possible influence on groundwater chemistry of known and well-documented polymetallic veins that exist throughout the area, as seen as green triangles on the map, which were historically mined for silver and locally contained metals such as lead, zinc, cobalt, and arsenic. The study area was divided into a 5 by 5 kilometer sampling grid instead of the conventional 10 by 10 kilometer grid, to accommodate the irregular spacing of domestic wells in the area. The target was one bedrock and one overburden well within each 25 square kilometer grid. The higher sampling density also increased the likelihood of detecting the known polymetallic veins, so it was a win-win. In the summer of 2024, fieldwork was conducted and groundwater samples were mainly collected from domestic wells. In total, 64 bedrock and 50 overburden samples were collected, including 8 samples from monitoring wells from the PGMN network. In addition, 17 quality control samples, including blanks, dupes, and reference materials, were also submitted to evaluate analytical accuracy and precision. Roughly 91 parameters were measured for each sample collected, including field measurements, observations, and laboratory analysis. Once the field and lab data were reviewed, QA/QC was done to validate the dataset, and homeowner reports were sent out to the participants of the study. This box and whisker plot on the slide compares total dissolved solid concentrations between overburden and bedrock groundwater wells in the study area. Overall, groundwater sampled from drinking water wells drilled into the Archean crystalline rocks typically had the lowest levels of dissolved solids and the least geochemical variability in the study area. This is likely due to more uniform bedrock mineralogy, leading to more consistent TDS values in bedrock wells. Overburden wells showed an overall wider range of TDS concentrations in the area, with a higher median value than bedrock wells. Additional sampling is planned in the Thunder Bay area in future years to infill significant data gaps in developed areas where wells exist. Ultimately, the data will be released in an MRD format compatible with integration into Northeastern Ontario AGGP database MRD 401. Thank you for your time today. If you have any questions, please feel free free to send them in the chat or send them to the email that's on the screen. Thanks.